Hello and good morning. So I've got a request of a teacher who's very beloved to me, asking me why quadratic sequences, when you're working out the first the a, if you like, an squared plus bn plus c. If that's a quadratic sequence, when you're working out the a, why do you have to divide the second difference by 2? And that's a really, really good question, and I didn't really mention it in class when we were doing it. And I just sort of mentioned the rule is to find the second difference, divide it by 2, and then that's your a. But I didn't really mention that, so I guess that's a shortcoming of mine, but let's do that now. So, of course, if this is any quadratic sequence, of course, the a cannot be a 0. If the a is 0, then that's going to sort of vanish, and I'm going to be left with a linear sequence. So the a can't be 0, but the b and the c, they can be whatever they want. So the condition there is that a has to be non-zero. It has to be something other than 0. It can be whatever we want it to be. And so if this is my quadratic sequence, then let's just start finding a few of the terms. So when n equals 1, the first term, well then an squared plus bn plus c, well what's that going to be? Let's break out a ruler. The first term, if n equals 1, I put 1 in there. 1 squared is 1. So I'm left with a plus b plus c, because I'm going to do 1 squared times a, b times by the 1 plus a c. So the first term is going to be literally a plus b plus c. And if you put numbers in here, so if you have, so for example, 3n squared plus 2n plus 5, the first term of that sequence would obviously just be what happens when you have n equals 1. So that's my first term. Second term, this time I'm going to put 2 in here, and I'm going to notice that I get 4a, because of course 2 squared, I'm pretty fast, times by a is 4a. 2 times by the b, that's a 2b, and then you have a c. Alright, that's my second term. Let's do the third term. And the third term is going to be, obviously, you can probably do this yourself, to be honest. If you want to pause it and have a go at proving it yourself, feel free to do so. It's a really good idea to do that. So substitute 3 in there. You get 3 squared times a, that's 9a, plus 3b, plus c. And let's go on for one more. Let's get what happens when n equals 4. So when n equals 4, I'm going to get 16a, plus 4b plus c. All right, let's start finding these first differences and then the second differences. So the first difference, so that's going to be this take away this. So the first difference for each of these is going to be that take away that, that take away that, that take away that. So of course we've got 3a plus b. The c's are going to cancel because c take away c, well that's nothing. 2b take away b, well that's a 1b. 4a take away 1a is 3a. So the first difference here is 3a plus b. Let's do the same thing for this one. 9a take away 4a, that's 5a. 3b take away 2b, that's again just a b. And c take away c, again that dies. It goes away. And the first difference in this case, 16a take away 9a, that's going to be 7a's. 4b take away 3b, that's just a b. C take away c, again that vanishes. So the first differences are these numbers here. So 3a plus b, 5a plus b, and then 7a plus b. And you can probably see why we're going to have to divide by 2, but we'll get to that hopefully as well in a second. So the second difference, that's going to be the differences between these first differences. So 5a plus b take away 3a plus b, that's going to be 2a. The b's are going to cancel, just like how the c's cancelled up there. Now here, 7a plus b, take away 5a plus b, that's just going to again be 2a. So the second difference is just going to be 2a in this case and 2a. So and that's why you notice that when you actually do that with a particular sequence of numbers, when you do work out the first differences and the second differences, you always get well, for a quadratic sequence anyway, your second difference just becomes a constant number. So at this point now, we've worked out that the second difference is always just going to be, regardless of what type of quadratic sequence it is, it's always going to be 2 lots of whatever that starting number is. So that's why at the very end then, to finish off, we take this second difference and we divide it by 2, because what we want to do is work out what the value of that is. And that's why, because we only want 1a, I'm going to divide this by 2. So if I do that, if I divide the 2a by 2, I get exactly the a. Right, and that's why we divide by 2. I'll try to do a quick example as well. So that. Let's have some numbers: 4, 10, 18, and 28. All right, so there's a quadratic sequence. Let's work out the first difference. 10 take 4, that's 6. 18 take 10, that's 8. 28 take 18, that's 10. The second difference, that's going to be 8 take away 6, that's 2. 10 take 8 is 2. All right. And so at this point, you've guessed it, this is going to be a monic quadratic. And that means it's going to be, divide that by 2, you get, of course, 1. And then it's going to be 1n squared. So basically, if I was to write this as an squared plus bn plus c, the a would have to be 1. So you'd have 1n squared, and then you could continue by working out the remainder. Okay. So we know it's 1n squared. So at this point, you'd say, what does the sequence 1n squared look like? Well, it looks like 1. 2 squared is going to be 4. 3 squared is going to be 9. And 4 squared is going to be 16. And of course, now I want to go from here up to the original sequence. So what am I gonna add on? I need to add on the sequence of numbers. I need to add on 3 there. I need to add on 6 there. I need to add on 9 there. And I need to add on 12 there. So if I know that if I add up these two sequences, I will get the original sequence. So this sequence is 1n squared, obviously. This sequence is pretty easy. You guessed it. It's just 3n. And so my final answer is just going to be 1n squared plus 3n. Or in other words, this sequence is represented by 3n squared plus 3n. And that's it. So thank you very much. Hope you enjoyed that. Goodbye.